Okay, here's warm-up 9.4.2. I'm going to graph some trigonometric functions here. I've got a sine function and a cosine one. So you have to know what the parent graph for these two functions looks like. Just in a nutshell, a sine function is going to be kind of an S-curve like that, and a cosine function would be sort of a little valley looking thing, although there's a reflection on this one, but we'll get to that in a minute. Okay, so let's start by finding the amplitude here. The amplitude is just going to be the coefficient that's in front of sine or cosine or tangent, whatever it is. Here it's sine. So my amplitude is going to be 2. And the amplitude is going to have to do with the height of the curve, and I'll get to that in a minute. But first let's find the period. So the period is going to have to do with the coefficient that's in this position after sine but before the theta symbol. So pi over 3 actually isn't the period. That's the k value. So the k value is pi over 3. Okay, and but that's going to lead me to the period. So the way I get the period for sine or cosine actually is with this little formula. It's going to be 2 pi over k. Well, k is pi over 3, so that means that this is going to be 2 pi over 3. Okay? Now, I still want to simplify this, so I'm going to think of this as division. So I'm thinking of it as 2 pi divided by pi over 3. And then I'm going to rewrite it as multiplication by flipping the fraction. So that's going to be 2 pi times 3 over pi. Okay? So when I multiply this together, I'll have 6 pi over pi. So the pi's are going to cancel out. And then I'm left with just 6. So my period is going to be 6. And that has to do with the distance from one end of the of a cycle to the other end. Okay. All right. So let's graph this cycle. So there's no shifting on this curve because there's nothing added or subtracted. So a sine curve is going to typically start at the origin, okay? And then what I'm going to do is use the amplitude. So since the amplitude is 2, I'm going to make a little horizontal line 2 units above this first point, and also 2 units below. So if this is the midline of my S-curve, and it is, it's going to be just the theta axis there, then the other points are going to be on these two dotted lines that I just drew. So since it's this general shape, that means I'm going to go up first to get to my next critical point, and I'm just going up 2 because that's the amplitude. So it's the height of the curve from the midline to the top. It's also the height of the curve from the midline to the bottom. So I go up, and then I'll go back down to the midline, and then I'll go down to that bottom guideline and back to the middle. Okay, and I can draw in my curve then. And these are the 5 critical points. Now this pattern would continue forever. So this is just one cycle of this sine curve, but it would continue in that same pattern in both directions. So I'd get an S curve that stretches on forever. Typically, though, I'll just graph one cycle, and it says just graph one cycle. So here it is. Okay. I also want to always label the axes. Well, the axes themselves are labeled, but I want to scale them. So the y-axis in my class, I just always have the y-axis. Each tick is 1 unit. So actually, I usually won't label the y-axis because it's just what it looks like it is. But the theta axis you definitely want to label, because the period is how the distance that one cycle takes up. So this goes from 0 to 6 then. So that means that this fourth tick out is actually going to be 6. Okay? So the way I graph these, the fourth tick is always going to correspond to the period for that reason. Okay? And then so, if I wanted to label these other points, well, halfway to 6 would be 3, right? And halfway to 3 would be 1.5. So each tick then is worth 1.5. So 1.5, 3, 4.5. And you don't necessarily need to scale every single tick on the axes, just as long as you get one of them. Really, for me, if you just get the that fourth point out where the period is, then that's fine in general. Okay? All right, and there is a one cycle. All right, so let's try this out with a cosine curve. One thing to watch out for here is we've got this negative. So what that negative is going to do is it's going to reflect my curve over the theta axis. So it's going to turn my curve upside down. So instead of being a valley like this, it's actually going to be a hill. And look, something like that red dashed line that I just drew, okay? Now the amplitude is always going to be positive because it's talking about the height, so I kind of just use that 3 on its own. So the amplitude is 3, okay? And then my k value, just like on the last problem, is going to be 1/2. That's not the period itself, but it's going to help me get the period. So the period's going to come from 2 pi over k. K here is 1/2, so 2 pi divided by 1/2. So I'll write this as division, and then in turn as multiplication. So if I flip 1/2, that's just 2. So my period then is going to be 4 pi. Okay. All right, so let's start graphing this. So with a sine curve, you're going to start at the origin, but with cosine, you're not going to start on the origin typically. I'm looking at the amplitude. So if this was my midline here, the amplitude is 3, so I'm going to go 3 units above to make a little line as a guide, and 3 units below the origin like that. Okay. And if there wasn't the reflection, I'd be starting up here, but there is a reflection, so I want to start down here actually. Okay, and then I've got kind of an S-curve happening. I'm just kind of following this pattern I'm going to oscillate between this bottom guideline, the midline, and the top. So next point's going to be there on the midline, then up to the top, then back down to the midline, and down here. And we're going to get what looks like a little mountain here. Okay, and again, this is just one cycle, so if you repeated this pattern, it would actually look like an S-curve. It'd look very similar to a sine function. It's just kind of shifted over. All right, and then my fourth point out is that's the period refers to how long the cycle takes, so that ends at the fourth tick, and that fourth tick then should be 4 pi. So my fourth tick is 4 pi, and I could get the rest of the tick. So each tick is going to be 1 pi here on the theta axis, and that's going to be 1 there again on the y-axis. And that's it for this warm-up, and I'll see you next time.